Hello students, this is Harish Konda. Welcome to my channel, the Chemistry Classroom. After a long time, so we are making a video. Please follow my videos. It is very useful to the students. So, one thing I want to remind, like, share, comment and subscribe. Don't forget to bell also. So today I am going to introduce one topic that is called isomerism in organic chemistry. So what I am discussing is isomerism. So what is isomerism? How we classify the isomerism? What are the compounds they are performing the isomerism? Now we discuss here. In generally in organic compounds, so many organic compounds they are performing the isomerism. So what is the isomerism now we see? Generally the two compounds having same molecular formula, but they differ. They differ either in the structure or in the spatial arrangement. I am repeating, the two compounds having same molecular formula, but they differ either in the structure or in the spatial arrangement. They form two different compounds. So the two compounds are called isomers. This phenomenon is called isomerism. They are having the same molecular formula, but they differ in the structure or they differ in the spatial arrangement. So for example, I write one compound here. You observe here. So one compound I am writing. This compound, if you observe, this compound is called butane compound. Why? Because all carbons are saturated carbons. Here we have only carbons and hydrogens. So the root word is alkane. What is the root word? It is alkane. Here alk equal to how many carbons? We have 4 carbons. So 4 carbons, alk equal to 4. So it is called but. So the compound is called butane compound. So what is the compound? It is butane compound. So if you see in this compound, how many carbons we have here? The 4 carbons we have. And we count the hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many hydrogens here we have? 10 hydrogens. C4H10 is the molecular formula for the butane compound. Now I write one more compound. You observe this compound. So this compound I am writing. So here all carbons are saturated. So here the first carbon, still it forms 3 bonds. Then second carbon also same, then third, then fourth, and so here every carbon is saturated carbon only. So here also the root word is alkane. So here alkane equal to 4 carbons, but the 3 carbons and 1 is side chain. The side chain is methyl side chain. The compound is propane. So the compound is called methyl propane. So what is the compound? It is methyl propane. So here you observe, so how many carbons here we have? 4 carbons. So how many hydrogens you count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here also how many hydrogens you have? 10 hydrogens. So this compound molecular formula also C4H10. Now we observe these two. The two compounds are having same molecular formula. The two compounds are having the same molecular formula, but they are forming two different compounds. One compound is called butane, the another compound is called methyl propane. So even though they are having same molecular formula, but the two compounds they differ. That's why the two compounds are called isomers. So what they have? They are having same molecular formula. Iso means same. So they are having same molecular formula, but the two compounds they differ. How they are differed? By the structure they can differ, by the spatial arrangement. What is spatial arrangement? Around the molecule, around the atom, how the different atoms, how they are accommodated. Around the molecule, the space, around the atom, what it is called, it is space. Around the atom, the space, how the space, the molecules or groups or elements are attached. That is called spatial arrangement. So based on the structure or based on spatial arrangement, we are getting isomers. That phenomena is called isomerism. So now we discuss about the isomerism classification. So based on that, the isomerism classification, one by one we discuss what are the isomers we have, what is the isomerism we have, one by one we discuss. Okay. So here, before discussing about the isomerisms, first we classify this isomerism. Here generally the isomerism, it is classified into two. The one is called structural isomerism. One is called structural isomerism. The second is called stereo isomerism. The one is called structural isomerism. The second is called stereo arrangement. Based on the structural arrangement, they differ. How they are differing? The two compounds they are having same molecular formula, but how they are differing based on the structural arrangement, how the structure we form, based on the structural arrangement they differ. That's why the isomerism is called structural isomerism. If spatial arrangement they differ, they are having same molecular formula, but they differ in the spatial arrangement, that isomerism is called stereo isomerism. So how they differ? Based on that isomerism we classify into two. The one is called structural isomerism. The second is called stereo isomerism. Again it is classified into four. The one it is called chain isomerism. The second it is called position isomerism. The third it is called functional group isomerism. And the fourth it is called metamerism. So based on the structure, how they are differing, they differ in the chain, they differ in the position, they differ in the functional group, they differ in the metamerism. So the structural isomerism, again we are classifying into four. The four comes under structural isomerism. The molecular formula same, but they differ in the structure. How they are differing? So one by one we discuss later. So here the stereo isomerism, the spatial arrangement. So what I am discussing about the spatial arrangement around the atom, how the atoms or how the elements, how the groups they are arranged. Based on that the stereo isomerism we are doing. So here the stereo isomerism, again it is classified into two. The one is called configurational isomerism. The second is called conformational isomerism. So one is called configurational isomerism and the another one is called conformational isomerism. So here the isomerism we are discussing. So the two compounds are having same molecular formula, but they differ either in the structure or in the spatial arrangement. So if they differ in the structure, that isomerism is called structural isomerism. If they differ in the stereo, that is spatial arrangement, they are called stereo isomerism. So here the structural isomerism, again it is classified into four. The one is chain, the second is position, the third is functional group isomerism, and the fourth one is metamerism. So one by one we discuss, so what is the structure, how they are differing in the structure, how they are formed the isomers. Now one by one we discuss. So in the structural isomerism, the first isomerism we are discussing, that is called chain isomerism. What is the isomerism? It is chain isomerism. So how they are differing? So how in the structure they are differing? Now one by one we see. So the chain isomerism is the first isomerism, the first structural isomerism. To explain this chain isomerism, with example only we discuss. Now I am writing one example. You see this example. The compound, if you observe, this compound is saturated compound. All carbons are having only sigma bonds. The carbons are having carbons and hydrogens only we have. That is called alkane compound. Why? Because it is saturated hydrocarbon. The compound is alkane. So it is alkane compound. In the alkane compound, alk equal to how many carbons we are getting here? 4. So that is called butane compound. What is the name of the compound? It is butane. So here you see how many carbons we are getting? 4 carbons. The number of carbons are 4. And hydrogens, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many hydrogens you have? 10 hydrogens. The C4H10 is the molecular formula for this compound, butane compound. So it is called normal alkane compound. Why? Because here we don't have any side chain. We have the straight chain only. So it is called normal alkane, enalkane. In that enalkane, the compound is butane. So here I write one more compound. You observe. This compound I am writing. So here also the compound is having only carbons and hydrogens. So remaining they are hydrogens. So here the compound is having same 4 carbons. The hydrogens, if we count, how many are getting? 10 hydrogens. So what is the name of this compound? If you see, here we have one side chain. The side chain is called methyl. So the compound is called methyl. Here the carbons are 3. So it is methyl propane. The compound is methyl propane. If you see here, the first compound you observe that is butane. The second compound is methyl propane. Here these two compounds are having same molecular formula. For the first compound C4H10, second compound also C4H10. But how they are different? So in the first compound we don't have any side chain. In the second compound we have one side chain. So how they are different? They are differed in the side chain. The first compound is not having the side chain. The second compound is having one side chain. The two compounds, they are having same molecular formula, but they are differing in the side chain. That's why these two compounds are called chain isomers. The phenomena is called chain isomerism. So one more example we see. For example, I am writing this compound. I am writing this compound. This compound, if you see, so the compound is saturated. Here carbon and hydrogen only you have. How many carbons you have? 5 carbons. So hydrogens you count, the hydrogens are 12 hydrogens. C5H10. So here the compound is normal alkane, enalkane. So how many carbons? 5 carbons. So root word is alkane. Here alk equal to how many carbons you are getting? 5. So the compound is pentane compound. What is the compound? It is pentane. So now you see the one more compound I am writing. So here also, how many carbons we are getting? 5 carbons. The hydrogens if we count, so how many hydrogens we are getting? The same 12 hydrogens. This compound also having C5H12, the molecular formula, same molecular formula. But this compound you observe, here we have one branch. What is the branch? It is methyl. The methyl butane. The compound is called methyl butane. What is the compound? It is methyl butane compound. You observe these two compounds are having same molecular same molecular formula, but the two compounds are having different. Why? Because the first compound is not having any side chain, the second compound is having one side chain. So they differ in the chain. That's why this is called chain isomerism. So one more I write. You see, observe here. So this compound also having same 5 carbons. The hydrogens if we count, the same 12 hydrogens only we have, that is H12, that is C5H12. This compound also C5H12, the same molecular formula. But what is the name of the compound? You see, here we have two side chains, they are methyls, they are on the 2 and 2, so they are called 2,2 dimethyl propane. What is the compound? It is 2,2 dimethyl propane compound. Here you observe, in the first compound we don't have the side chain. In the second compound we have one side chain. In the third compound we have two side chains. The three are having same molecular formula, but they are differing in the side chains. The first compound is not having the chain. The second compound is having one side chain, and the third compound is having two side chains. So they are having the same molecular formula, but they differ in the chain. That's why they are called chain isomerism. Understood? So there, the molecular formula is same. So what you are getting in the compound, they are having, they differ in the chain. So that's why they are called chain isomerism. And one point you observe and one point you remind. So always in the chain isomerism, the parental chain should be same. It is not same. Here the first compound you see the butane. The second it is called propane. The parent chain is different. The one is butane, second is methyl propane. The parent chain is different. Here observe in the second example, the parent chain is pentane, here the parent chain is butane, here the parent chain is propane. When it is performing the chain isomerism, the parental chain is differed. So, the butane and propane, here it is methyl propane, it is pentane and methyl butane, dimethyl propane. They are differing the parent chain also, so we have to keep in mind. So, when the chain isomerism we are discussing, they are differed in the chain. That's why they are called the chain isomerism. Why? Because the chain structure we are differing. That's why it is called structural isomerism. In that, the chain isomerism we are discussing. That is our first structural isomerism. Okay. The second we discuss. So the second isomerism, that is called position isomerism. So how it is performing? Now we see the position isomerism. So with example only we discuss. I am giving one example. You see this example. So now only we discuss this compound. This compound is having 6 carbons. So C6. How many hydrogens here we have? 14 hydrogens. C6H14 is the molecular formula for this compound. Here we have one side chain. What is the side chain? It is methyl. So the compound is called methyl pentane. The compound is methyl pentane. So number of carbons we have. So we have to number it. So the first carbon, second, third, fourth and 5. So on the second carbon we have the side chain. So it is called 2-methyl pentane. What is the compound? It is 2-methyl pentane. So the formula is C6H14. The name of the compound is 2-methyl pentane. Here I am writing one more compound you observe. So this compound I observed. So how many carbons here you have? 6 carbons. So hydrogens if you count, how many hydrogens here you have? The same 14 hydrogens only. In the compound also you have same 14 hydrogens, C6H14 only. The compound if you observe, we have one side chain. The side chain is methyl. So the compound is methyl. This is pentane. So it is methyl pentane. So number of carbons we have. So we are numbering 1, 2, 3, 4 and 5. On the third position, so we have the methyl. So it is 3-methyl pentane. Now we observe in the first compound, the methyl side chain. In the second compound also we have the methyl side chain. In the first compound, methyl side chain at the second position. In the second compound, the methyl side chain at the third position. So the two are methyl pentanes only. This compound is methyl pentane. This compound also methyl pentane. But in the first compound, the methyl at the second position. In the second compound, the methyl at the third position. So what they are differing? The side chain they have same only, but they are differing in the position of the side chain. That's why they are called positional isomerism. If the molecular formula is same, but how they are differing? They are differing in the position of the side chain. That's why they are called positional isomerism. It is a second isomerism. Okay. The third we discussed, it is called functional group isomerism. So what is the third one we see? Functional group isomerism. Here you observe one thing. So what they are differing? They are differing in the functional group. They are having the same molecular formula, but how they are differing? They are differing in the functional group. So here we have some pairs of functional groups, how they are differing. One by one we discuss with the example. The first pair I introduced. Now we see the first pair. One compound I am writing. You compound this compound, you observe. Here what is the functional group? Here it is alcohol is the functional group. The root word is called alkanol is the root word. Here how many carbons here you have? That 2 carbons, it is C2. And how many hydrogens you have? The 6 hydrogens and 1 oxygen. What is the molecular formula? It is C2H6O. Here the root word is alkanol. Here alk equal to 2 carbons. The compound is ethanol compound. The first compound I am writing. In the compound, what is the function group? Here it is alcohol is the function group. The name of the compound is ethanol. The molecular formula C2H6O. So I write one more compound here, you see. Here the compound, here we have the one functional group. The function group is called ether function group. What is the function group? It is ether function group. That how many carbons you are getting? The same C2 carbons. Hydrogens, we count the 6 hydrogens and 1 oxygen. The molecular formula is same. C2H6O, C2H6O. Again, the compound is alcohol compound. Here, what the compound you are forming? It is ether. What is the name of the compound? It is alkoxyalkane is the root word. Alkoxyalkane. One is alkoxy, the second is alkane. So, what is the alkoxy? It is methoxy and it is methane. The two compounds we observe, the two compounds are having same molecular formula C2H6O only, but one compound is alcohol and another compound is ether. So the two compounds are having same molecular formula, but how they are different? They differed in the function group. That's why this pair, alcohols and ether pair, they are called functional group isomers. It's the first pair. And one more I introduce. So second compound I am writing, now you observe. So this compound I am writing. So what is this compound? It is, so here the CHO group we have. So the root word it is alkanol. What is the root word? It is alkanol. Why? Because it is aldehyde. In the alkanol, how many carbons we have? 3 carbons, so it is C3. And hydrogens, how many you have? Same 6 hydrogens and 1 carbon, 1 oxygen. C3H6O is the molecular formula for this compound. Here alk equal to 3 carbons you have. So the compound is called propanol compound. What is the compound? It is propanol. So same I write one more compound here. You observe this compound. So here we also having one functional group. That functional group is called ketone functional group. What is the functional group? It is ketone. The root word is alkanone. What is the root word? It is alkanone. Here alk equal to how many carbons? 3 carbons. So the compound is called propanone compound. The compound is propanone. Here also we have 3 carbons and hydrogens are 6 and oxygen is 1. We observe these two compounds. The two compounds are having same molecular formula C3H6O, C3H6O. But one compound is having aldehyde functional group. The second compound is having ketone functional group. They are having the same molecular formula, but they differ in the functional group. That's why they are also called functional group isomers. It is one more pair. Aldehydes and ketones are functional group isomers. This is our second pair. And one more I introduce this compound if you observe. Here the compound is having the functional group carboxylic acid functional group. It is COOH function group. The root word is alkanoic acid. So here alk equal to 3 carbons you have. The compound is called propanoic acid. What is the compound? It is propanoic acid. Here how many carbons you have? 3 carbons. Hydrogens are 6 and oxygens are 2. What is the molecular formula? It is C3H6O2. The compound is propanoic compound. So here I write one more compound you observe. So here also how many carbons you are getting? The same 3 carbons and hydrogens are 6 and oxygens are 2. The both compounds are having same molecular formula C3H6O2, C3H6O2. But this compound belongs to ester compound. This is carboxylic acid. This is ester. That is called methyl methanoate. The compound is called methyl methanoate. So methyl methanoate. The one compound you are forming the acid compound, the another compound you are forming the ester compound. So what they are different? They are having the same molecular formula, but they differed in the function group. So one is acid function group, the other one is ester function group. So the 3 pairs we are discussing here, the one it is alcohols and ethers. They are having the same molecular formula, but they differ in the functional group. So alkanols and alkanones, that is aldehydes and ketones, they are also having the same molecular formula, but they differ in the functional group. Acids and esters, they are also having the same molecular formula, but they differ in the function. That's why they are called functional group isomers. So they are this one third exam. Third one it is functional group isomerism. That is just third structural isomerism. Here The last one, it is called Metamerism. So this is the fourth structural isomerism. So when we are discussing the Metamerism, so compulsory one condition is required. So what is the condition? The function group should have two side chains. The function group should have two chains in, so then only it performs the Metamerism. With example only we discuss. So I am writing one compound, you observe this compound, this is ether function group. What is the function group? It is ether function group. Here we have two side chains. The two side chains we have, so it can perform the Metamerism. Now we observe in this compound, so how many carbons we have? The 4 carbons we have, it is C4. So hydrogens are 10 hydrogens and 1 oxygen, C4H10O. The compound is alkoxyalkane. The root word is alkoxyalkane. So there is ethoxy and another one is ethane. So the name of the compound is ethoxyethane. So here you observe the function group is having two side chains. In one side chain you have 2 carbons, in another side chain you have 2 carbons. So I am writing one more compound if you observe. So here you see, here also we have 4 carbons and hydrogens are the same 10 only and oxygen is 0. Only one side. Oxygen is 1. So what is the molecular formula? Here also C4H10O. Here the compound is how they differ, you see. In the first compound the oxygen is having 2 side chains. In the first side chain 2 carbons, second side chain 2 carbons. In the second compound the same ether function group only, but in the side chains, one side chain you have only 1 carbon, in another side chain you have 3 carbons. So one is the name of the compound, it is methoxy and it is propane. The compound is methoxypropane. Here you see, so what they are differing, the function group, the 2 sides they have the side chains. In side chain the number of carbons are different. Here in the first side chains we have 2 carbons, in the second chain we have 1 and 3 carbons. So how they are differing? In the function group the 2 side chains, in the side chains the number of carbons are different. So with this, so what they are performing, the Metamerism they are performing. Even though they are having the same molecular formula, what they differ, the function group side chains, in the side chain number of carbons are different. So this phenomena is called Metamerism. These 4 they are comes under structural isomerism. They differ in the chain, they are called chain isomerism. They differ in the position, they are called position isomerism. They differed in the function group, they are called function group isomerism. They differed in the side chain of the function group, that is called Metamerism. These 4 comes under structural isomerism. And one more isomerism we have to discuss, that is called stereo isomerism. The spatial arrangement towards the atom. Towards the atom, how the molecules are arranged. Based on that, so we are getting the stereo isomerism that we can. Dear students, lastly I am discussing one topic. Please like, share, comment and subscribe. Don't forget to bell and don't skip the video. Up to the end you read, you see. So why? Because that every topic is very important for your education. For your further studies it is very important. The isomerism we are discussing. So each and every point is very valuable for you. So that's why please don't skip the video until the end you see. So based on that you can learn something that is very useful to you. So don't forget to see all the videos and up to the end you see, and don't forget to bell also. Like, share, comment and subscribe. Thank you.